All right, this is the video to go over the examples that I teach in class with the law of sines. If you have not watched my law of sines overview video that describes when you can use the law of sines for certain triangles, you probably should go back and watch that one first. All right, example number one. In triangle ABC, A equals 30 degrees, B equals 70 degrees, and A equals 8.0 centimeters. Find the length of side C. So as the steps in the previous video showed, the first thing we always need to do is sketch a triangle or draw a triangle. Now, the triangles that I draw, and probably the triangles you will draw, aren't going to be to scale. In other words, we're not going to have A be exactly 30 degrees, B equal to 70 degrees, and A be exactly 8 units or 8 centimeters in length. That's okay. The triangle that we draw is just to give us something to work from, a visual of what we're working with. All right. So step number one, I'm going to draw my triangle. So I'm going to come in here and we'll just sketch a triangle over here. And we'll call this angle B up here. And so that was 70 degrees right here. We'll call this one down here angle A. And that one was 30 degrees. And this, of course, would be angle C. And we know that side C is 8 centimeters in length. So this over here is side C. And this is 8.0 centimeters in length. I'm sorry, side A is supposed to be 8.0 centimeters in length. We're finding side C. So side A, that would be this side over here, is 8 centimeters in length. Now, to be able to do this, again, we need 3 of 4 pieces of information because I have all of the ratio for angle A side A. I'm definitely going to use it. And since I want to find the length of side C, it would be in my best interest to find angle C so that I could use its ratio in comparison to the ratio for angle A. However, right now we do not know angle C. But as I mentioned in the previous video, when we run into something like this, we can always find the third angle in a triangle because we know the sum of the angles in a triangle in a plane is 180 degrees. So triangles A and B together add up to be 100 degrees. And if I subtract that from 180, that tells us that angle C would have to be 80 degrees. And so now that I know the measure of angle C, I can go ahead and set up my two ratios as a proportion. So I'm going to have the sine of 30 degrees divided by that side length that's opposite of angle A. And in this case, that is that 8.0 centimeters. And we're going to set this equal to the ratio for angle C. So we're going to have sine of 80 degrees. There's the sine of angle C. And the one thing that we're trying to find that we do not know is the length of side C. Now I have my proportion. I'm going to go ahead and cross multiply. So I'm going to have side C times the sine of 30 degrees is equal to 8.0 times the sine of 80 degrees. Now, I want to solve for side C, but right now it's being multiplied by the sine of 30 degrees. So to undo that, I need to come in and I'm going to have to divide both sides by the sine of 30 degrees. Now on the left-hand side, that sine of 30 degrees in the numerator and the 1 in the denominator will simplify out. Those would just become 1. And so what I will be left with here is I will have that C is equal to 8.0 times the sine of 80 degrees divided by the sine of 30 degrees. And at this point, once I have an equation and I have the thing that I want to solve, I'll go ahead and go to my calculator. Now, when we're using our trigonometric functions, it is very possible that we're going to end up with an irrational number, which means I'll just need to round once I get there. A second thing with our calculator, unless somebody has already done so for you, your calculator will usually default to radians if somebody has reset it, or if they haven't ever changed it since it's been reset. So if you're working with angles that are measured in degrees, the first thing you always need to look at on your calculator is to see what measurement for angles your calculator is set to. Radians is another measure that is used in a lot of trigonometry, but for the applications we're going to do in here, we'll be using degrees. Where you're going to change that is you're going to press the mode key, and you will see that right here. It looks like 1, 2, 3. The fourth option, you can choose between radian and degree. And what this does is it allows you, now, once I press enter here and degree is flashing, when I use my trig function, sine, cosine, and tangent, or their inverses, it's going to assume that the number I type in is in degrees versus radians. Or if I'm using my inverse functions, the answer it's going to be return is going to be in degrees. So now let's go ahead and figure out what side C is equivalent to, or approximately at least. So I'm going to take 8.0 times the sine of 80, and I don't need to put a degree sign with that because I just told the calculator that this thing is going to be operating, that all of my angles that I put into my trig functions would be in degrees. And so here we end up with 15.75692405. So this is an irrational number. So as far as my answer goes, depending on what the problem instructs you to do, and there were no instructions this one, so I'm going to round it to 3 decimal places. But in this case, side C would be approximately 15.757, if we round to 3 decimal places, centimeters in length. And again, that's an approximation because we ended up with an irrational number. Now, I left myself some additional room in case I ran out of room on this slide, so we'll skip over that slide. And we'll move on to example number 2. In number 2, it's a little bit different. They're not asking us for something specific. They're saying, find the missing parts of triangle ABC. So they're asking us to find everything that's missing. So we're going to find all the missing sides and all the missing angles. And they tell us that angle B is 34 degrees, angle C is 82 degrees, and side A is 5.6 centimeters. So that means we're going to need to find, let's see, angle A, and we're going to need to find both sides B and C. So we're probably going to use the law of sines twice here. So again, first step, we're going to go in, we're going to sketch ourselves a triangle. And so we will take angle B, and we'll put it down here this time. And we're going to make that 34 degrees. We'll put angle C up here. It's going to be the 82 degrees. And that means angle A would go down here, which we don't yet know its measurement. But they do tell us that side A is 5.6 centimeters. So they ask us to find all the missing parts. Well, angle A is one of our missing parts. So I'm going to write out that the measure of angle A is equal to. Now, again, I can use the fact that the sum of the angles for a triangle in a plane is 180 degrees. So I need to figure out what is angle A here. Okay. Well, to do that, what I'll do is I'll just take 180 degrees minus the sum of the two angles that are given, 34 degrees plus 82 degrees. And I believe that's 116 degrees. But if you're not sure, just go to your calculator. 180 minus the sum of 34 and 82. And it tells us that angle A should be equal to 64 degrees. So there's our first piece of information. That's our first missing piece. So we know in here, instead of putting a question mark there, we can write in 64 degrees. All right. Now, with that, that gives us enough information for one full ratio for our law of sines. Now, we're supposed to find all the missing pieces, so we still need to find side B and side C. So at this point, we have options, and we can choose to find either side. I'm going to go ahead and find side B first, and then we'll come back and take a look at side C. If you feel like finding side C first, you could absolutely do that. So I'm going to go ahead and write my first ratio, and that's going to be the one involving angle A. So I'm going to have the sine of 64 degrees divided by the side length of side A, which is 5.6 centimeters. And we're going to set this equal to the sine of angle B. And angle B in this problem we were told was 34 degrees. And we're going to go ahead and try and find side B. So I've got my proportion set up. So I'm going to go ahead and cross multiply. I'm going to have B times the sine of 64 degrees is equal to 5.6 times the sine of 34 degrees. And then to solve for B, I will need to divide both sides by the sine of 64 degrees. And when I divide there on the left side of the equation, those are going to simplify out and become 1. So this will leave us with B is equal to 5.6 times the sine of 34 degrees divided by the sine of 64 degrees. So this is going to give us the second missing piece. We already know angle A. We already found that to be 64 degrees. So let's figure out what side, the length of side B should be, approximately, of course. So we're going to say 5.6 times the sine of 34. And I know it's degrees because my calculator is set to degrees. divided by the sine of 64 degrees. And we get that side B should be approximately, and again, I'm going to do 3 decimal places because it's not specified as to what I need to do. So I'm going to do 3.484. So we're going to say that side B is approximately 484. That's right. 484 centimeters in length. Okay. So I've got that side B is approximately 3.484 centimeters. All right, now to go on to find side C. Now, I recommend using either a ratio that you were given when finding this stuff, or not this stuff, but anything in a triangle that's missing, or something that was easy to calculate, like the angle A, because it was precise, it's not rounded. So to find side C, I'm going to start again with my ratio of side A. So that was sine of 64 degrees, because we found earlier that angle A was 64 degrees. Side A was 5.6 centimeters. And now we're going to go with the sine of angle C. And we're going to use the ratio for angle C. And so they told us that angle C was 82 degrees. And we do not happen to know the length of side C. That's what we're trying to find with this second proportion. So we're going to go ahead and cross multiply. We'll have C times the sine of 64 degrees is equal to 5.6 times the sine of 82 degrees. And then I am going to divide both sides because I need to isolate C. I'm going to divide both sides by sine of 64 degrees. Now again, here on the left, these are going to simplify out. And that means 1 will be left behind. And that's just going to leave us with C. But what I do to the left-hand side, I have to come and do to the right-hand side. So I also need to divide this by sine of 64 degrees to maintain equivalency. So now I've got 5.6 sine of 82 degrees, or I should say times the sine of 82 degrees, divided by the sine of 64 degrees. There we go. And so we're going to go back to our calculator to get an approximation for this. So I've got 5.6 times the sine of 82, and we know it's still in degree. It's always good to double check. Divided by sine of 64 degrees. And we get that side C is about 6.1699. Now I'm going to round it to 3 decimal places. So that will put us at 6.170 because of the double nines. So that means that in my diagram, side C is going to be about 6.170 centimeters. So they asked us to find all of these pieces of information. So I'm going to go back and I'm going to summarize them all. So the measure of angle A we found to be 64 degrees. Side B we found to be approximately, what did we say side B was? 3.484 centimeters. And side C is approximately 6.170 centimeters. And so that concludes us finding the missing parts to triangle ABC.